Hello students. Today we will learn about relation between zeros and coefficients of polynomial. In our previous video, we have already talked about geometrically how to find zeros of polynomial and how can we transform polynomial into polynomial equation. So let us start today with a linear polynomial, say ax plus b. We know to find its zero. Convert it to equation, that is ax plus b is equal to 0. If we solve this equation, we get the value of x as minus b upon a. This means when we substitute minus b upon a in polynomial, we will get value of polynomial as 0. Now tell me, what are the coefficients of this polynomial? Yes, exactly, a and b, where a is leading coefficient and b is coefficient of x raised to 0, also called constant. From our previous equation, we can see that 0 of linear polynomial is minus b upon a. Therefore, alpha is equal to minus b upon a. We can clearly see that 0 of linear polynomial is related to its coefficients. To understand this clearly, let us put it like this. 0 or alpha is equal to minus b upon a, which is equal to minus constant term upon coefficient of x. We can clearly see that 0 of linear polynomial is related to its coefficients. Now, does this happen in the case of other polynomial too? Are their coefficients related to their zeros? In this video, we will try to answer these questions. For that, let us take a quadratic equation, ax square plus bx plus c. Degree of this polynomial is 2, so there will be two zeros, say alpha and beta. Their relation with the coefficient is alpha plus beta is equal to minus b upon a and alpha into beta is equal to c upon a. How do we reach to this generalization? And is this true? Let us verify. Let's do it by taking example. Say we have p of x is equal to 2x square minus 8x plus 6. On factorizing it by middle term splitting method, we get its factor, which are zeros also. To find zeros, let's take p of x equal to 0. Therefore, 2x square minus 8x plus 6 is equal to 0. Therefore, 2x square minus 2x minus 6x plus 6 is equal to 0. On solving, we get 2x into x minus 1 minus 6 into x minus 1 is equal to 0. Therefore, 2x minus 6 into x minus 1 is equal to 0. Taking 2 common, we get 2 into x minus 3 into x minus 1 is equal to 0. Now, these are prime factors of p of x. Now let's find the zeros. X minus 1 is equal to 0. Therefore, x is equal to 1, which is our alpha. And x minus 3 is equal to 0. Therefore, x is equal to 3, which is our beta. Now let's do sum of zeros. That is, alpha plus beta is equal to 1 plus 3 is equal to 4. We can also write 4 as minus of minus 8 upon 2, which is equal to minus of coefficient of x upon coefficient of x square. Or another way, bring p of x is equal to 2x square minus 8x plus 6. Now alpha plus beta is equal to minus b upon a. Here in this polynomial, minus b is equal to minus of minus 8, which is equal to 8, and a is equal to 2. On substituting this value in this equation, we get minus b upon a is equal to 8 upon 2, which on solving gives us the value is equal to 4. Now let's see the multiplying part. Alpha into beta is equal to 1 into 3 is equal to 3. We can also write 3 as 6 upon 2, which is equal to constant term upon coefficient of x square. Alternately, consider p of x is equal to 2x square minus 8x plus 6. Now alpha into beta is equal to c upon a. Here in this polynomial, c is equal to 6 and a is equal to 2. Now substituting these values in the formula, we get c upon a is equal to 6 upon 2, which on solving gives us the value 3. Thus, we have established and verified that this relationship between coefficients and zeros is true. In general, if alpha and beta are the zeros of quadratic polynomial p of x is equal to ax square plus bx plus c, where a is not equal to 0, then you know that x minus alpha and x minus beta are the factors of p of x. Therefore, ax square plus bx plus c is equal to k into x minus alpha into x minus beta, where k is a constant. Now, when we take k common, we get k into x square minus alpha plus beta into x plus alpha into beta. On further solving, we get kx square minus k into alpha plus beta into x plus k into alpha into beta. Comparing the coefficients of x square, x and constant terms on both the sides, we get a is equal to k and b is equal to minus k into alpha plus beta and c is equal to k into alpha into beta. This gives us alpha plus beta is equal to minus b upon a and alpha into beta is equal to c upon a. Now let us see the relationship between zeros and coefficients of cubic polynomial. For any cubic polynomial, say ax cube plus bx square plus cx plus d, where a is the leading coefficient and b is of coefficient of x square and c is a coefficient of x and d is constant term. It will have 3 zeros, alpha, beta, gamma, as the degree is 3. The relation between its zeros and coefficient is as alpha plus beta plus gamma is equal to minus b upon a, which is equal to coefficient of x square upon coefficient of x cube. Alpha into beta plus beta into gamma plus gamma into alpha is equal to c upon a, which is equal to coefficient of x upon coefficient of x cube. Also, alpha into beta into gamma is equal to minus d upon a, which is equal to minus constant term upon coefficient of x cube. Verify this by yourself with one example I give you. Say p of x is equal to 3x cube minus 5x square minus 11x minus 3. Zeros of this polynomial are 3, minus 1 and 1 upon 3. So students, let's quickly summarize what we have learnt. We know that any real number, say a, it is a zero of polynomial p of x only if p of a is equal to 0. That is, on replacing variable with the value of a, if we get polynomial as 0, then we say that it is a zero of that polynomial. We saw the relation between the zeros and the coefficients of polynomial, which is for linear polynomial of the form ax plus b, where x is a variable, then the zero of polynomial alpha is equal to minus b upon a, which is equal to minus constant term upon coefficient of x. For quadratic polynomial of the form ax square plus bx plus c has 2 zeros, let us say alpha and beta. Then the sum of zeros, that is alpha plus beta, is equal to minus b upon a, which is equal to minus coefficient of x upon coefficient of x square. The products of zeros, that is alpha into beta, is equal to c upon a, which is equal to constant term upon coefficient of x square. For cubic polynomial of the form ax cube plus bx square plus cx plus d, say there are 3 zeros, alpha, beta and gamma. Then the sum of zeros, alpha plus beta plus gamma, is equal to minus b upon a, which is equal to minus coefficient of x square upon coefficient of x cube. the sum of the product of zeros, that is alpha into beta plus beta into gamma plus gamma into alpha is equal to C upon A, which is equal to coefficient of x upon coefficient of x cube. The product of zeros, that is alpha into beta into gamma, is equal to minus d upon A, which is equal to minus constant term upon coefficient of x cube.